Alright, so this is a review of 4.2, which is titled Estimate the Product of a Decimal and a Whole Number. As we talked about in, topic 3, I'm not a big fan of estimation, but here it makes it a lot easier to multiply. So this is what I'm going to kind of go through with you and help you review and look at. So let's go ahead and get started. So this, I know part of the directions are cut off, but it says one way to estimate a product is to round each number to the greatest place. Okay, that's important. Greatest place. When it says the greatest place, it is talking about the whole number. Okay, the greatest place. That's important. Okay, it's not talking about the ones place, it's not talking about the tens place, the greatest place. It's not talking about the tenths, hundredths, thousandths, greatest place. So you're looking at the whole number. So if we estimate 3 6/800 times 19, and we were to round, well, I'm going to look at this whole number right here, 3. This 6 tells me that that 3 is going to round up. And I know that because 0, 1, 2, 3, and 4 tell me to stay the same. 5, 6, 7, 8, or 9 tell me to round up. Okay, so 3 and 68, if that 6 makes that 3, it goes to a 4. So 3 times, oh, sorry, I did this backwards. That doesn't go there. So over here, if we look over here, 3 and 68 is going to round to about 4. 19, I'm looking at this 1, that 9 tells me that that 1 needs to be bumped up to a 2. And I just replace that digit, this digit, with a 0. So it's going to be about 20. So basically, 3 times, or 3.68 is really about 4 times 20. And I know that 4 times 20 is, I can count by 20s, 20, 40, 60, 80. So here I'm just going to fill in the blank. So 3.68 times 19 is about 80. Now, keep in mind that we are going to have to discuss if it's an underestimate or an overestimate. So because I rounded up to both numbers, this would be considered an overestimate. Okay, we overestimated the product. So that means my product might be a little bit smaller than 80. Okay. If I look at compatible numbers are numbers that are close in value to the actual number and are easy to add and subtract, multiply, or divide. So here in the example, they said that 24.8, 25 is a compatible number because it's easy to be multiplied. It's also, if you look at it, similar to rounding because that 8 would make that 4 turn to a 5. 4.21 is, we're going to say it's close to 4. It's also, just like rounding, if we're looking at that 4 and we look at the 2, that 2 tells me that that 4 is going to stay the same. So they've got 25 times 4. So what is 25 times 4? Well, think in quarters. If I've got 4 quarters, and they're all 25 cents, how much do you have? You have $1, right? So 25 times 4 is 100. Okay? So this would also be an overestimate. Okay? Alright, so let's look at this one. It says estimate by rounding. So here we're just going to focus on rounding. 158. If there's nothing here to round, but I can look at this 1 right here because we're rounding to the greatest place. That 5 tells me that that 1 needs to be rounded up to 2. So we're going to say the 158 rounds to 200 because it's closer to 200 than it is 100. And then 0.32, well, I have no whole number. This 3 would make it stay the same. So I'm going to now look at the tenths. The number behind the tenth place says, well, it rounds to, 0.3. Now I can estimate 200 times 0.3. 3. And if I do that, then I can just either do the standard algorithm and say 200 times 3. But remember, it's 0.3. But if I want to pretend that this is a whole number, I've got to move one place to the right. This is important. I'm going to put that little 1 right there. 3 times 0 is 0. 3 times 3 is 0. And 3 times 2 is 6. Then I have to move my decimal place back to where it was, one place. So it equals about 60. Okay, so you could also say that, if you were looking at compatible numbers, which we're about to do in a second, that this could be a 1, and it could be 200 times 1, and it'd be 200. So we're just estimating. There is no right or wrong answer as long as you're in the ballpark of the exact answer. Okay. So let's go over to the next one, and let's look at estimate by using compatible numbers. Well, estimate 158 and 0.32 by using compatible numbers. Okay. Well, 150, and they chose 150 because 150 is easy to multiply than 150. It's easier to multiply than 158. And we can say that 0.32, we can use 1 as a compatible number. So 150 and 1 are compatible numbers. So if we estimate 150 times 1, we know that anything times 1 is itself, so our answer is 150. Okay. Compatible numbers and rounding go, hand in hand. So this question, So first, before I move on, would you consider this an underestimate or an overestimate? You can pause the video and think about it. What do you notice that's different from this question versus this question? So if I were to look at this question, I would see that they dropped 158 to 150. That's 8 numbers. That's an underestimate. So I'm going to write, this one is an underestimate. But yet, they also rounded 0.32 or used compatible numbers to 1. So it also could be an overestimate. But which one do you think it is the most? Is it an underestimate or is it an overestimate? I would say that this is an overestimate. And here's why. Because there are more numbers between 0.32 and 1 than there are 150 and 158. So that's how you determine that. And if we go back and look at this one, is this an overestimate or an underestimate? Well, we rounded 200 from 158. That's a big jump. Okay, it's a little less than 50. And then 0.3, it stayed the same. So this one would too be an overestimate. Okay, so now let's look at this one. It says estimate the product using rounding or compatible numbers, whatever floats your boat, okay, or whatever is easiest for you. Well, I think that rounding is easiest. So I see this 5 here, and I know that 5 is going to automatically make this 0 a 1. So I'm going to say 1 times, and I think 29 is close to 30. So 1 times 30 equals 30. So my answer is about, and the key word is about because we're estimating, about 30. And this is an overestimate because I chose a bigger number on both of them. Okay? So, here's some examples for you to try at home. Pause the video when you see them, then you can unpause the video to check your answer. So, estimate 0.36 times 157. Second example, 1.52 times 394. And the third example, 5.7 times 103. Okay, so pause the video, attempt to do these extra problems, and then unpause it to get your correct answer. So, I'm going to round on some of them, and some of them I might use compatible numbers. It's up to you. So I'm going to look at 0.36, and I'm going to say this 6 makes that round to 4.4. And I'm going to multiply, and I'm going to say 157, that's close to 160. So if I go over here and I do the standard algorithm, which is 160 times 4, which is 0.4, and I know that I got to move one place to the right in order to make it a whole number. And I got to one place, and I got to move it back when I'm finished. 4 times 0 is 0. 4 times 6 is 24. Drop my 4, carry my 2. 4 times 1 is 4, plus 2 is 6. So then I have to move my decimal one place back. So my answer would be about 64. And I'm going to write about above it because that's the key word. About. It's an estimation. Okay, the next one. 1.52 times 394. Okay, so I'm looking at the greatest value. I got a 1 here. That 5 tells me that that needs to be bumped up to 2. I'm going to multiply 394. I think that's close to 400. Okay, so I'm looking here. That 9 tells me that 3 goes to 400. Okay, so I know 2 times 4. 2 times 4 is 8. All I got to do is place these two zeros right there, right behind that 8, and my answer is about 800. And then the last one, 5.7 times 103. Well, I'm looking at this number. The 7 tells me that the 5 should go up to 6. And I'm going to use a compatible number here, and I'm going to say that 103 is close to 100. If I multiply 6 times 1, that's 6. I've got to place these two zeros behind it, so my answer is about 600. Okay? So, your answers may vary, and that's okay. But just to give you an idea and keep practicing these at home, you can also go to Khan Academy, and they will also be a great help and resource to you as well. Alright? So I hope this helps.